So now, here we have 3 series blue LEDs. They're connected end to end. The same amount of current is flowing through all of them, somewhere around about 3 milliamps of current. Looks like it's at least 3 right there, maybe a little bit higher, because that will be like anywhere between 3 and 4 on the display there. It's not as accurate as a multimeter, though. So, in any case, we have the 3 blue LEDs. So color is important: blue, green, I think purple. Certain colors, they drop about 3 volts. They have a forward voltage of about 3 volts per LED. So when we're working with 12 volts there, each one of them is dropping 3 volts, leaving 3 volts across the 1000 ohm resistor in this case. And there you can see it's really bright right there. All 3 of the LEDs are really bright, with about 3 milliamps of current going through them. So we do the math using Ohm's law. We got 3 volts across the 1000 ohm resistor. The LEDs drop some voltage, 3 volts, but they do not set current. They're going to let current flow freely once you get about 3 volts across them. And so the remaining voltage is going to go across the resistor. It sets current based on the voltage across it. So 3 divided by 1000 is 0.003 amps, which is the same as 3 milliamps of current. So now, when you're building these simple circuits for the first time and stuff, it's a good time to also take multimeter measurements of it. So we're going to look at the voltage first. I just got to set it to V. This does the rest. If there's numbers, set it to a number voltage higher than you can expect to measure. And this is set to DC right now. You could change it to measure AC right there, but we're going to measure DC. So now we can look at the supply voltage again. That's at 12 volts, positive supply to negative supply right there. I ticked it up just a little bit because we do get a little bit of losses wherever there's resistance, where like there's connections and stuff. But there you can see we're falling a bit short of the 3 volts right there, which can be expected. A lot of it depends on how much current is flowing through. I don't have to go right to the leads of the LED. I can go to these other points right here. That's called a node. Basically, there's almost no resistance between these 2 points, so it doesn't matter if I measure there or there, and so on. But yeah, we're a little bit short by a little more than 0.1 volts of the 3 volts. So we will get more current due to more voltage across the 1K resistor right there. So I'm going to quick estimate about 0.4 volts extra across the resistor. So instead of 3 volts, we'll have somewhere around 3.4 volts across it. And so that is important for how much current is flowing through here. There's also the tolerance of the resistor. So they're not perfect. It's not a perfect 1000. Actually, it might be, but you would have to measure it to know for sure. But we'll go to milliamps right there. And we're going to measure the current. You got to put current through the meter, and you got to be careful. You don't want to measure a voltage source, the supply rails right there, directly, because I have the power supply current limited. But if the power supply current is not limited, more current will go through the meter than the fuse can handle, and the fuse will blow. So you want to make sure you never put more current through a multimeter than what it is set to measure right there. So yeah, we got 3.47 milliamps of current flowing through the circuit. So we expect about 3.48 volts across the 1000 ohm resistor to get that. So as I said before, you want to be careful with accidentally putting current through the meter. You don't ever want to do it when it's set to measure current. So we are going to get it off of measuring current. If there's a power button, set it to a voltage setting. This has an off setting, so I'm just going to set it to off. So in any case, that's about it. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.